In this video, the topic to be discussed is flame sensor. Flame sensor, smoke sensors, fire sensors, etc. are part of safety equipment that help us in keeping our homes, offices, and stores safe from fire accident. Generally, flame sensors are used to detect the fire accidents in factories, in offices, homes, stores, etc. The main function of that flame sensor is detect the fire accident. Second one is almost all modern houses, apartments, malls, cinema halls, theaters, office buildings, and the shops are equipped with such safety equipment. It means flame sensors, and it is mandatory in some regions to fire safety devices. Third important point here is commercial fire safety devices are advanced with a lot of complex circuitry. If you want to implement a DIY fire or flame detection application, then this project might be helpful. The aim of this project is detect the fire accidents in some important places. Important warning here is this project is just to give you an idea on how to implement a simple flame sensor using Arduino platform, and we do not guarantee its commercial applications. For commercial applications, we go for another technology. Here, so for simple demonstration with Arduino, we use this project. A small flame sensor. The distance is very, very small. Some important point here is under normal conditions, the output from the flame sensor is high. Generally, this is the sensor, flame sensor. Flame sensor under normal condition, the flame sensor output is high. The flame sensor output is high. When a sensor detects a fire, this is the fire. When a sensor detects a fire, its output becomes low. Output is low. This is the some important point regarding flame sensor. This is the flame sensor. When output is high, flame is not detected. When the sensor detects any fire, its output becomes low. This is the technology used with the flame sensor. Next, applications. Flame sensors are very important devices in detecting fire, and they can be used in variety applications like areas like car or automobile, fire fighting robots, garage safety equipment, warehouses, cinema theaters. So many applications are there. This is the IR sensor, IR flame sensor. The IR flame sensor has three terminals. One is this one is data. First one, this one is ground. This one is VCC. This is the IR flame sensor diagram. Next one. This one is important points of that IR flame sensor. Here 10 kilo ohm pot. This one is the 10 kilo ohm pot. PW or LED. LED is glow for operation. This one is the phototransistor. This one is LM393 voltage comparator IC. This one is IC. Digital output. Here the digital output LED. PW or LED. Two LEDs are there. This one is PWR LED. This one is digital LED, digital out LED. This one is VCC ground DO. This flame sensor has 3 terminals: VCC, ground, and DO. DO means data pin. This one is the data pin. Pin diagram of the flame sensor. Sketch. Important one is under normal condition, the output from the flame sensor is high. Output from the flame sensor is high. At that instant, LED is off. Buzzer is off under normal condition. Fire is not detected. Fire is not detected under normal conditions. Under normal condition, the data pin output is high. Data pin output is high. Okay, next, when the sensor detects any fire, the main function of sensor is detect the fire. The data pin output goes to low. Output is low. Buzzer is on. Indicates some flame is detected or fire is detected. These are the important, very important conditions. 2 conditions related to flame sensor. First one, in this sketch, LCD interface with Arduino. LCD interface with Arduino. First one. Second one is a LED interface. LED interface with Arduino. LED interface with Arduino. Third one is a serial monitor. These are the 3 important actions we'll introduce in this sketch. First one is LCD. First statement here is library. This one is library. / include less than liquid crystal.h greater than. This library must include at the initial point because LCD interface will use here. That is the reason this library must include in the code. Next one, we have to make connections between LCD. This one is LCD. This one is LCD and Arduino board. We have to make connections between these 2. LCD has 16 pins. Arduino board has 0 to 13 digital pins. 13 digital pins. Here in the second statement, by using liquid crystal gap LCD 13, 12, 11, 9, 11, 10, 9, 8. These are the digital pins of the Arduino. 13 is generally used for RS, register select. 12 is used for enable connectivity to the LCD. RS is the register select pin of the LCD. E is the enable pin of that LCD. 13th is the digital pin of that Arduino board. 12 is also digital pin of that Arduino board. These are the 11, 10, 9, 8 are the digital pins of the Arduino board are connected to D4, D5, D6 and D7 data pins of that LCD. By using this second statement, we have to make connections between the LCD and the Arduino board. The LCD has 16 pins and the Arduino board has 0 to 13 digital pins. Here, three types of interfacings are there. First one is LCD. Here, in case buzzer also, third one, serial monitor, buzzer. Whenever fire is detected, the data pin goes to low. The data pin goes to low. Buzzer is on. The LED is on. Indicated on that LCD screen is the fire is detected. Buzzer is on. Buzzer interfacing. Buzzer interfacing is also important. Buzzer interfacing. LCD interface with Arduino, LED interface with Arduino, serial monitor, buzzer interfacing with Arduino. That buzzer has two terminals generally, ground terminal and VCC terminal. Now that buzzer declaration is indicated here. Integer, buzzer tone. This is the 4 means 4th digital pin of that Arduino board. LED interfacing is also included in this project. Integer, LED pin 5. 5 means 5th number digital pin of that Arduino board. And flame sensor pin. Generally, the flame sensor is also 5th one is flame sensor interfacing with Arduino. Interfacing with Arduino. Flame sensor interfacing with Arduino. Flame sensor. The flame sensor has 3 pins: data pin, VCC, and ground pin. The data pin is assigned to 3rd digital pin of the Arduino. Next, initially the integer flame response is 0. Integer flame response is 0. Next, integer contrast, CONSTRAT, contrast. It indicates contrast variation of the LCD. Generally, potentiometer is used to vary the contrast of the LCD. In this case, need not use potentiometer, just by use analog write. 6th pin of that Arduino board. This is the pulse width modulated pin of that Arduino board is connected to contrast pin of that LCD. Contrast pin. Generally, 3rd pin is the contrast pin of that LCD. Is connected to 6th one. 6th digital pin of that Arduino board. 90 means that contrast value. By using this simple statement, to avoid the use of potentiometer in this project. Next one, LCD wide setup. Initially, LCD dot clear. LCD is clear. LCD dot begin 16,2. 16 columns and 2 rows. Begin with these two. Serial dot begin 9600. That means the speed of the operation between the devices is 9600. That is the baud rate. Okay, here we use a buzzer tone. Buzzer means fire is detected. Buzzer is on. That means it indicates some output. Pin mode, buzzer tone output. Next one, whenever fire is detected, the LED is on. The LED is on means output. Here LED pin mode, LED pin output. Pin mode, flame sensor pin input. That means the output of the flame sensor. Data pin is the output of the flame sensor. that is connected to input to the Arduino board. That is the reason here input. Flame sensor pin input. For contrast variation, we use write here analog write. Delay 100 milliseconds. These are some important declarations at the beginning of the program. Next step is the void setup. Flame response. Here we use digital pin. Here for integer, flame sensor pin is 3. This is the digital pin of that Arduino board. That is the reason we use digital read. Digital read flame sensor pin. That is the flame response. The flame sensor pin is whether it is high or low based on the fire detection. Under normal conditions, the flame sensor pin is high. Okay. Under fiery detection conditions, the flame sensor pin is low. These are the high or / low conditions. Digital write. Digital read means high means 1, low means 0. Digital means 2 values, 0 and 1. That is here my definition is flame response. Flame response. Initially, the flame response is 0. Integer flame response is 0. Integer is declared here. If flame response is low, if flame response is low means fire is detected. Fire is detected already right here. If the flame response is low, detects any fire, flame response is low, data pin output is low, buzzer is on, fire is detected. LED is also on. LED is also on. LED is also on. Here, digital write, LED pin is high, digital write, buzzer tone high, LCD dot set cursor 00 and first row and first column, LCD dot print, fire is detected. LCD dot set cursor 0,1, second row, first column, LCD dot print, the LED is on, delay is 100 milliseconds. These are the actions to be initiated when flame response is low. Flame response is low means fire is detected. This is the very important point. Flame response is low means fire is detected. Fire is detected means LED is on, fire is detected, buzzer tone is high, LED pin is high. Next, else. Else means here here important serial dot print ln line flame response here means flame response is equal to low means here 0. 0 is indicated on the serial monitor. We will see in a demonstration. 0 is indicated on the serial monitor. Here, else means serial dot println flame response. That means high. Flame response is high means under normal conditions, any fire is not detected. The LED is not on. Buzzer tone is low. That means buzzer tone is not action. LCD dot set cursor 00, first row and first column. LCD dot print flame is not detected. LCD dot set cursor 0,1, first row and second column. LCD dot print, the LED is off. Delay 100 milliseconds. Here in this sketch, important point here is the data pin of that LCD. The data pin of that not LCD. The data pin of that flame sensor is low. Low means fire is detected. Fire is detected indicated on the LCD. The LED is on, buzzer is on. Under normal conditions, the data pin of that flame sensor is high. The flame sensor is high. At that instant, the LED is off, flame is not detected, buzzer is not on. These are the some important actions related to flame sensor. Some important connections here. Some important connections we have to made here. These are the LCD interface. Ground is connected to here. Ground is connected to ground. Here VCC plus 5 volts is connected to VCC. Contrast pin is the sixth pin. Sixth pin of the Arduino. Here, this is the pulse width modulated pin. Sixth pin is connected to contrast pin of that LCD for contrast variation. Register select is connected to 13th pin. See the 13th pin. Read write pin is connected to ground. Enable pin is connected to 12. Enable pin is connected to. This is the digital 13th pin is for register select. Digital 12th pin is for enable one. Enable one. Here D0 is not D0 data pin 0, data pin 1, data pin 2, data pin 3 are not used. 4, 5, 6, 7. 4 is for 11th pin. This one is 11. This one is 10, 9, 8. 9, 8. 11. 11th pin is meant for D4. D4. And the 10th pin is meant for D5. 9th pin is meant for D6. And 8th pin is meant for D7. These are the interfacing. This is the LED is connected to 5 volts to resistance 220 ohms. This is the 5 volts. Last one is ground. LCD plus 5 volts. This one is a plus 5 volts through resistance. This one is a LCD interfacing with Arduino. Arduino. Next step is these are the 3 pins. This one is data pin. This one is ground. This one is VCC. That VCC is connected to here. VCC is connected. This is the ground pin. The ground pin is connected to here. Here in this code, integer flame response pin is 3. Flame response pin is 3 means third pin is connected to. This is the third pin. Third pin. This one is the data pin is connected to third digital pin of the Arduino. VCC is connected to plus 5 volts. And ground is connected to ground of that Arduino. Ground of that Arduino. VCC is connected to plus 5 volts. This one is the plus 5 volts is connected to VCC. Okay. Flame sensor interface is also completed. This is the flame sensor. Flame sensor interface with Arduino. With Arduino is completed. Next buzzer. This one is buzzer is connected to ground of that Arduino board. This one. Buzzer another terminal is connected to 5 volts. 5 volts of that Arduino board. Buzzer interface with Arduino is also completed. Here buzzer buzzer tone. Here buzzer tone is equal to So 4. Buzzer tone is equal to 4. Buzzer tone is equal to 4 here. Here, fourth pin of that digital pin. Fourth digital pin of that Arduino board is connected to one of the pin of that buzzer. This interface is also completed. Next one, LED. For LED, the pin is 5. LED pin is 5. Here, fifth pin through some resistance, 220 ohms. This one is anode. This one is cathode. This one is ground. The fifth pin of that Arduino board, digital pin of that Arduino board, is connected to anode of that diode, LED diode, through 220 ohms. Light emitting diode through 220 ohms. Cathode is connected to ground. These are the interfaces. Flame sensor interface with Arduino, buzzer interface with Arduino, LED interface with Arduino, LCD interface with Arduino. These are the 4 interfacing concepts included in this project. Okay. Generally, flame sensor is a sensor which is used to detect the fire. Under normal conditions, the flame sensor output is high. In our sketch, whenever the flame sensor output is high, the buzzer is not on. The buzzer is not on. LED is not. LED is off. Fire is not detected. Whenever a fire is detected, the data pin of that flame sensor is low. The buzzer is on. Buzzer is on. LED is on. Fire is detected, indicated on the screen. These are the some important concepts related to flame sensor. If you like this video, please subscribe the channel for further updates. Thank you. The project demonstrated here is a flame sensor. Initially, flame is not detected. The LED is off. This is the LED. This one is the LED. The LED is off condition. The flame is not detected. This one is the sensor, flame sensor. This one is the code related to this project. Code related to this project. This one is the code related to this project. Here the state is 1. Here the state is 1. The pin state is 1. The sensor, the LED is off. This is the sensor. The flame is not detected. Now flame is recognized. The LED is on and flame is detected. Flame is detected. The state is 0. The state is 0. Flame is detected. LED is on. The state is detected. Okay.